Alright, hey guys. We are still looking at similar figures, so I just picked a couple to do. Kind of similar to what we talked about last time, just more of an algebra problem. So for similar figures, we are setting up proportions to solve for missing sides. All three sides in these triangles should grow or shrink by the same scale factor. So for number one, I'm going to use the lettering at the top to help me set up my ratios. So first, let's kind of match up what goes with what. So JK, the first side here on the bigger triangle, is going to match up with NM. Alright, then the last two, KL, will go with the last two letters ML. So KL, which is right here, is going to go with ML, which is down here. So you really want to identify what matches up with what. Okay, so let's use these first, and then obviously JL will go with NL. JL is the first and the last letters here, so it'll go with the first and the last letters here. So then let's just focus, because we have two variables on these. That's why these are a little bit more difficult. Let's focus on setting up proportions to solve for x first. I'm going to put the bigger triangle over small equal to the bigger triangle over smaller triangle. Remember, you could go the opposite way. You just want to be consistent in the problem. So I'm going to put 40 over 16, and then I'm going to set it equal to going back to the bigger triangle on top, which is x over 14. Then I'm going to cross multiply. And then I'm going to solve. So then I'm going to take 560 divide that by 16, x equals 35. Good. Let's see what the question's asking. Use that proportion to find the variables. Yeah, so x equals 35. We do have to find the second variable though. It said the value of each variable, so x and y, not just x. So now I'm going to go back and set up a second proportion to solve for y. For a proportion, when you're cross multiplying, you need two fractions. So I'm going to still use that 40 over 16, except for this time on the second setup, I'm going to do 45 over y. So now notice the variable is on the bottom, but it doesn't really matter when you cross multiply. And then we have 16 times 45 is 720. Then you're going to divide by 40. So 720 divided by 40 gives you y equals 18. So there are your two answers. It would not be good to set this up. Let's say we started with the big triangle still, and we did 45. We said JL matches up with NL. I'm looking at the top always because these are turned. So JL matches up with NL, so that's y equal to, now I'm going to go back. I am still putting the bigger triangle on top. Good, but what's the issue with this? KL goes with ML, which is 14. When I cross multiply, I'm going to get two variables. You never want to have two variables in your setup. Another thing you don't want to do is to start by saying, oh, okay, I'm going to put 40 over, that goes with 16, and then I'm going to say 14 over x. No, because then I did the bigger over the smaller equals the smaller over the bigger. That's not good. You could say, though, you could start with the smaller one and say 16 over 40 equals 14 over x, and then cross multiply. Then you'd get the same thing when you cross multiply as what I got over here. This one I did bigger over smaller equals bigger over smaller. This setup, which is totally acceptable, I did smaller over bigger equals smaller over bigger. Stay consistent with how you set up your fractions. Okay, moving on, we're going to jump down to number 4 because that one's set up a little different. Alright, number 4, we have a smaller triangle and then a bigger triangle. Keep in mind that DB, 8, is not the length of the side of the big triangle. The big triangle, side AB, is 28. This is not the side of a triangle, so don't use that small length. These are the bases of the two triangles, though. Okay, so this one we only have one variable. Cool. Let's start, I'm going to start this time smaller over bigger. So I'm going to start with AD, which is 20. So if I need to, I'm going to look up here. AD are the first two on the smaller, so 20 matches up with AB. 20 over 28, it's easier to see what goes with what here. Equals, now I just have to make sure on top I go back to the smaller triangle. So 15 will go with 2x plus 3. Smaller over bigger equals smaller over bigger. Okay, go ahead and cross multiply. I will put this in parentheses and I will FOIL the 20 to the 2x plus 3. So we're going to get 40x plus 60 equals 420. Then you're going to subtract over your 60 and get 40x equals 360. Divide by 40, x equals 9. And that's all you needed to do here for your final answer. The hardest part is going to be setting up your ratios, making sure you know what lines up with what. On this side, 15, that's DE. Look up here. DE are the last two, so I know underneath DE has to go BC. The last two on that one. Usually I start with the first triangle or the bigger shape. Doesn't matter. All right, one more on the very back. It's talking about your scale factor, just to loop back to this. So your scale factor on number 10 is 3 over 5. You can write it as a fraction as well. So 3 over 5, and they want us to find the perimeter. So first let's start by labeling some of the sides. So we have 3 over 5. Let's start with LK goes with PQ. We'll label that X. So 3 over 5 equals 6 over X. How did I know to write this down? The smaller triangle will go on top because the smaller number in the scale factor was on top. This is a smaller triangle. Did I have to use this side? No, I could have used 15 over Y. Doesn't matter. Go ahead and cross multiply. So we get 3x equals 30. Divide by 3, x equals 10. So this side is 10. Now we can keep setting up our proportions to solve. I'll just use x, y, and z. Let's go ahead and put a y here and a z here. We have x equals 10. They want the perimeter, so they want the perimeter of PQR. That's this triangle. I'm eventually going to have to add these three numbers together. Okay, so let's go ahead and go back. And I can keep using the scale factor, but if I wanted to, I could use the 6 over 10 equals 15 over y. 6 over 10 equals 15 over y. Then you cross multiply. Okay, now we have y equals 25. All we need is our last side to figure out the perimeter. Now this time I could use same thing. I could use the 6 over 10 equals 12 over z. Again, make sure KM, that's the first and the last, does match up with PR. Yes, it does. That's the first and the last here as well. So let's just use the scale factor. I'll do 3 over 5. Just make sure you put the smaller triangle on top. So the 12 has to go over the z here. Then you cross multiply. You get 3x. I'm sorry, 3z equals 60. 3z equals 60. Go ahead and divide by 3. Z equals 20. And then add up your sides around. And your final answer for this one's 55. Remember, your perimeter is adding up your three numbers around.